Alright, this weekend's project is to make a resistance decade box, and the main parameters I set for this is that it's got to be built like a brick shithouse, and it's got to last me the rest of my life because I'm not going to build another one. I wanted something better than one of these. They're rebranded by everybody, but I don't see it lasting me for very long. So the main overview of what I'm doing here is I'm going to have two sets of 6 decades from 1 ohm, 10 ohm, 100 ohm, 1K, 10K, and 100K. The first set will be 5 watt, 1% wire wound resistors to dissipate a little bit of power, and the other set will be quarter watt, 0.1% resistors. For the 5 watt, I used Ohm's WN series, and that's their low inductance Art and Perry winding style, and they are 20 ppm. For the quarter watt, I used the Welwyn RC55 series. They are 0.1% and 15 ppm. I did want to use the half watt version, the RC65 series, but I had to order 500 of each value, so that wasn't going to happen. Aside from the decade, I'm also adding kind of a transfer standard using high precision metal foil resistors for the most part. That'll mimic the decades that I have, so 1 through 100K, and I'm also adding a 1 meg resistor. For the I think the 1 ohm and 100 ohm are 0.01%, and the other ones and the 1 meg is 0.01, I think, but the other ones are 0.005%, so it's better than the gear I got here, so it's good enough for chicken meters and whatnot. And apart from that, we can look at the case. This is a instrument enclosure made by OKW. It's a UK company, I believe, and it's made in the UK. This is the Unimet Plus 6 series, I think. I have the front panel out of it right now because I started to do some of the assembly. But if you order this, the front panel kit is separate. Unless you order, like I ordered from Allied and they spec'd it in, but that is separate. Along with the tilting feet, that's separate, and they do make PCB card guides that go in there. But it is a little bit pricey, but it is made in the UK, so it's a little bit of a price premium there. I sprung for this because I was thinking that I'd like to make a couple other things, and it's only 4 screws to take the front panel off. It's the same thing on the back side, so I thought about having kind of a multi-purpose piece of gear here, and I did order a couple spare front panel kits so I can just swap in and out what I'm using currently. But if we do a little walk around, if you look at the bottom, here's the tilting feet kit, and that is you only get the 2, so I did have to order another set because I want these on the other side as well, since the tilting bail is of course only good for one side. If you look at the tilting bail, it's very nice. It has 2 push buttons on either side that lock into a couple different positions, and I like that better than a lot of the other cases where you have to spread it apart, which will end up cracking the plastic eventually. So we can just lock that into place there, and looks very nice. Probably one of the better test equipment enclosures on the market, and they have a bunch of different sizes and whatnot. So apart from the resistors, the most important part, I think, is the switches. There's only 2 parts to this, so as long as you don't overload the resistors, they should be fine. But getting the switches to last is probably, I think, more important. So we can take a look at those, and I will post all the part numbers and stuff I use for the 50 people that watch this and either want to duplicate it or just want the part numbers of some specific part that I use in this project. So let's take a look at the switches. Okay, so these are the switches I'm going to be using. They're made by Grayhill, and this is their 19 series. I went with the 11 position switch because I wanted to have the complete decade on one switch, plus the position 1 for short. Of course, you can get away with just a 10 position switch. You just have, say, 1 through 9 ohms, and the next decade would be 10. Like I said, I wanted it all in one. So the ratings for this switch, they are rated to 120 volts AC or DC at 1 amp, and I believe they're rated for 6,000 operations, and they consider an operation from position 1, and in this case to position 11, and then back to position 1. That's one operation, and that's at full rated load. So I'll be using this for low current stuff, so it should hopefully last a lot longer than that. Now the contacts are a silver alloy, and everything else is either silver alloy or silver plated, and I went with silver because it is a better conductor than gold, except you have the pesky problem with corrosion, and I have been looking into solutions for that. I'm not too keen on putting grease on the contacts, so I looked at the Deoxit stuff, and I did order their technician's kit, and just to get a little bit of grab bag of what they got. And it seems, just doing a little bit of research on the internet, that there's two camps, for and against, some saying it's a godsend and others saying it's snake oil. The only thing I'm really concerned about, as far as its corrosion inhibiting properties, I won't be able to know that for quite a while, but only thing I wanted to test is just to make sure that the film, that their gold solution or whatever, just doesn't increase the contact resistance, having that layer of whatever that stuff is. And so I got this little test apparatus here, and I just want to do a little bit of a side-by-side comparison. So this first one, just clean it. They're already pretty clean, but just to clean it with their Deoxit Contact Cleaner, and then put their gold whatever stuff on there. And then the other one, I'll just, I know CRC doesn't make a difference, but I'll probably use like Tarnex or something a little more aggressive, and just have dry contacts, just to see what the difference is. So first we'll get a baseline with the initial contact resistance, and I do have a milliohm meter that can measure down to 10 microohms, so that'll give us a good baseline, just to make sure, just to see that it doesn't increase resistance or anything like that. So let's get the test bench set up here, and we'll get our initial measurements from new switches, and we'll do a little bit of cleaning and see where that leads. Alright, we got the milliohm meter out, and we'll make sure we do make sure it reads 0. Alright, now we're zeroed, and we'll get the initial contact resistance here, and we'll just do it on position 1 to get our baseline. If I can get them on there. And we'll just check for repeatability, so 1.4 milliohms. So about 1.41 milliohms, we'll say. And for the other one, say 1.32. Alright, 1.32 or 33 milliohms. Alright, first we'll use just their Deoxit Contact Cleaner, and we'll give that a little bit of a squirt here. And then with the other one, I'll use just a little bit of Tarnex. Let's see if we can get underneath the switch. Alright, now for the Deoxit, their gold protectant here. We'll just put a little bit of that on. And I'll work the switch a little bit. Alright, probably should at least wipe off some of a little bit of the excess. Alright, now let's do our check just to make sure that it didn't make a dramatic difference. Oh, it actually improved it quite a bit. Well, by quite a bit, it's not a whole lot, but it is different. So it didn't make it worse. So I guess I feel good about putting it on the contacts. And man, a slight improvement on the other switch as well. So there you go. That was interesting. Yeah, I don't have any hesitation putting it on there. So we got our switches, and it's time to start getting the resistor soldered on, and so that'll be the next step. Okay, so here's the first semi-assembled switch. I did go through and clean all the oxidation and oils and stuff off the contacts as well as the resistor leads, so we try to minimize that as well as oils. I got them on end to try to minimize the space that they're going to take up in the box, and I did try to make sure to get as good a crimp as I could as far as bending the leads around, so we're not just relying on the solder itself for connection. So pretty much got to solder this up and rinse and repeat another 11 times, and we'll be ready to put them in the box. Alright, so here's the completed 5-watt set, and I hope it meets the brick shithouse status as far as being a little bit over-engineered and hopefully built to last. I come from an industrial background, and stuff you design and build and put on the floor definitely has to be over-engineered, since most operators are ham-fisted morons, so if you don't overbuild it, they're going to break it. So it definitely could be better, but there has to be some kind of price cap for this project, as it is getting pretty expensive. So let's take a closer look at what we got going on here. So we're coming in, and the wire I used was a 14 gauge silver plated wire, and you can get that from a McMaster car for like $1.70 a foot. It's not very expensive. The setter I used was by WBT, I think it's made in Germany, and it has the highest silver content that I've seen at 4%. It definitely is pricey. That's why I buy it in small rolls like that. So we're coming in, and we're coming into pin 1 on our switch, and that is our bypass position. So it'll just go directly out to the common, and that'll be position 0 on our knob. So if we go to position 1, which would be pin 2, we're putting in the first resistor in line and out the common, and so on and so forth until we get to pin 11, which will tie in our 10th resistor. Now we're coming out the common and going into pin 1 on the second switch, and so on and so forth until we get to our output. I also have a shielding ground terminal, which will be mounted to the integral binding post that's in the box. Now if you take a look at our little transfer standard that mimics what I got going on here, I ended up using the 1 ohm for a current source. It was a nice 4-terminal job, and it came in handy for that, so I have to get a new one. But we're going to have 1 ohm, and then 10, 100, 1K, 10K, 100K, and 1 meg. and I did use different binding posts for those. Those are a Cinch Johnson Connectivity brand, and they are silver plated. But Mauser had a little bit of an overstock right now, and they were like $3 a piece, so they're a lot cheaper than the $7 or $8 a piece Pomona gold plated ones here that I use for the mains, but they're not going to get a whole lot of use, so that should be just fine. If we take a closer look at the switches, wasn't quite happy with the spacing between them as far as how far the knobs are apart, but I was kind of limited by what I got going on with the resistors. The lead length is just long enough to put them on end like that. It's not long enough to get them completely vertical to make sure that the wiper clears, so that's why they're kind of fanned out like that. But it's just an aesthetic thing. As far as functionality, they're just fine. I don't know if it'll show up on camera, but they do have a pretty glossy appearance to them. I did put a couple coats of silicon conformal coating, and I used had one of these little nail polish bottles, and came in handy and worked very well. And I just put that on there to try to slow down the corrosion process, so made sure to coat the resistors, the leads, the pads on both sides, essentially the whole switch on the other side, because these contacts are essentially pop riveted on, so they are exposed, so those are fully coated. We take a look at the other ones I got here. So they are for the most part sealed, and as far as the other exposed contacts, as we've seen in the resistance demo, the gold stuff didn't affect it at all, so I have that coated on everything that I obviously couldn't put in silicon conformal coating. Hopefully it should last, and should give many years of service. But let's take a closer look at the transfer standard I got here. So here's a close-up of our transfer standard, and I tried to get the best that was available or in stock, so the tolerance is a little bit all over the place, but we have our 10 ohm at 0.05% and our 100 at 0.005, and that's the same through the 10K, and our 100K is 0.01, and our 1 meg is 0.01. So yeah, and until I get the replacement 1 ohm, I think that was a 0.1 or 0.01, but that should come in handy just for meter checking and things like that. You can see I didn't quite clean up all the flux on there. It is pretty stubborn. I don't know what they use in that solder, but it is really thick and really sticky. I do have a flux remover pen, but really couldn't cut it, so I just decided just to coat the whole thing and I'll just seal it in there. So let's take a look at the other side. And here's the other side. You kind of see the spacing between the switches just seems a little bit too far as far as the knobs, and these are the biggest ones that I could find as far as the diameter at 1.46 inches. You can see the numbers on the skirt and the degree angle between the two. Now I have to match the switch, and it's 30 degrees, and I think most of them are 30 degrees, so tried to offset them as much as I could, just a little bit over. I thought about possibly getting a vinyl overlay or something made to have a grid with the specs for our precision resistors, and to have, you know, times 1, times 10 and all that. So at the top we got our 1 through 100 and 1K through 100K. So that's pretty much it. Let's take a quick look at the 0.1% decades. Here's the 0.1% class resistor decades here, and I was able to get them a little bit closer together since the resistors don't take up any space, but the switch arrangements, everything's the same as the other side. Everything's silicone coated, which will probably inhibit some of the heat dissipation, but oh well. Let's take a quick look at the other side. And again, I thought about possibly getting a overlay made for this, but be able to get them a little bit closer. Just with the size of the box and everything, they just look out of place. And like I said, that there's just not too many on the market that are very large. So let's put them in the box, and we'll just do a couple of little spot checks on the ranges here, and see how well if it passes or fails. And here's the completed unit. As you can see, it's kind of a beast. I probably wouldn't recommend building something this big just for a resistance box, but I plan on using it for other things possibly. So you can see here we have the vanity plates, and they just have some split pins, and those are relatively easy to pop off. This covers up the screws, and I did make sure to set the binding post spacing to 3/4 of an inch, which is the standard spacing. And that was a relatively easy task, as I got a pretty badass CNC mill. Here's a picture of it. Now, for some reason, I tried to export the G-code to it, and it didn't accept it, so I ended up having to do it manually. I think I know where I went wrong, and I think if you look closely, you'll be able to see it as well. It might have something to do with it being 60 years old, but that's just my guess. If we take a look at the other side, I did get the tilting feet for that as well. So we can have it both sides here. And this is our 0.1% decades, and I do have some extra space here for possibly some precision voltage references or current source. I'm not quite sure. But first thing we want to do is check the initial contact resistance, just direct short through the switches, and then we'll do some spot checking of the ranges. So let's do that. And 0.1% is 12.45 milliohms. And our 5-watt set is 14.5 milliohms. So now let's do some spot checking of some of the ranges. So let's check some of the ranges here on the 1% 5-watt resistors. I did rail out the meter for the leads as well as the contact resistance. I just wanted to actually check the resistors themselves. So we'll just go up to the 4 range. It's just a 40,000 count meter, and just to get the highest resolution. And they all seem pretty good to me. And we got our 100 ohm range. And our 1K. And the 10K. And the 100K. So that looks alright, and next we'll check our little standard here, and let's get that set up. So we're looking at our 10 ohm resistor, and it's just scraping it in. I think it's 5 milliohms plus minus, and just barely cutting it on that one. And it should also be 5 milliohms on this one, which doesn't go low enough, but there's our 100 ohm. And our 1K. And 10K. And there's our 100K. And our 1 meg, which is not metal foil, so I should turn the frequency down for that, but there's our 1 meg. So now let's look at the 0.1% decades and see how those check out. Alright, I did the same thing on this side. I railed out the leads as well as the contact resistance just to check the resistors. So we got our 1 ohm, and 2, 3. And we got our 10. And like before, we'll just go up to the 4 range. At our 100. And our 1K. And they all seem to be within range, and definitely good enough for what I'm going to be using it for, so pretty happy with it. And we got our 100K. There you go, looks pretty good to me. And it's probably a little bit crazy to have 2 sets. I probably should have just picked one or the other, but between the 2 they should last me quite a long time. So that's pretty much it. Off to the next project. And here's a little preview of the next project. I actually started this last year, and I've just been kind of putting it off, but what it is probably the longest wireless ice tip up out there. And with this setup, with a little bit of testing we did, we were probably pushing 2 miles. I actually have a whole range of prototypes that I made, and I was hoping that the first one would work. It was 2.4 gigahertz and actually didn't require any programming, essentially. So, but that was probably only good for like 1,500 feet, and that wasn't good enough. So this is the 900 megahertz version, and essentially alarm. It'll have a temp sensor, probably a tilt sensor. Know if it got bumped around, maybe some other things, but like I said, I'm getting to the hard part, and that's the programming. And I don't know a whole lot about C, and so I'm essentially gonna have to teach myself. But I might do like a part 1 development video, just showing how I got to this point, and which will probably set myself up for failure, as I won't be able to figure out the programming. But hopefully that's not the case. So that's what I'm working on, and I'll try to get started on this again, and hopefully make some progress, and hopefully it won't be too bad, because I'll have to have 3 of them in a network, because it's the max you can have, and we'll have a base station, and I'll have to have a remote, or a wireless touchscreen remote to connect to the base station, as well as to be able to take it out into a shanty, which will probably be the hardest part to figure out. But this is where I'm at so far, and it's just a little preview. So hopefully we'll get something out on it, and I'll hopefully make some progress.